Hello, this is lesson 122, holding a lead state. Well, the first thing we're going to do is open up lesson 121. So we might change the title because we're going to modify this now. Holding a lead state. And you might be wondering, why are we doing this? Why are we holding a lead state? Well, I've got a switch here to show you. This switch is a toggle on and off, but you'll see that I click it once and it changes. Okay, that would turn something on and off, and you'll see that's a really bulky switch. Actually, that's the smallest on-off switch I could possibly find, but a lot of the time you need to use smaller switches, especially in industry. If you're making a control panel or something like that, you're going to have a small switch called a tactile switch, and a tactile switch doesn't go on and off. If you press it down, it's on, and if you lift it off, it's off. So we need to actually put some control in here so that the microcontroller knows if it's been pressed down and then up to trigger a change of state, so that we can hold one state at a time. So to do that, as I said, we have to indicate to the microcontroller when it goes down and when it goes up. Well, when it goes down, it's called closed, and when it goes up, it's called open, because open breaks the circuit, okay? And when we push it, it's called closed. But that doesn't really tell us what's happening inside. You see, when it's closed, it's actually connected to ground, so it's low. And when it's open, it's connected by a pull-up resistor, that little resistor at the front there, to your VCC, or your positive voltage. And so that means pressing it is low and lifting it up is actually high. And so the open and close thing doesn't really indicate it for us. So let's have a look at these input tools. So you'll see in the input tool, that's how we've got a high test and a low test. So as we said, a high test is actually testing to see if it is not pressed. We might actually call this, instead of open, we're going to call it released. Okay, so the switch is released. And when we go to the low test, so it's been pressed, okay? Because as we said, it connects to ground, and that makes it go low. So switch is pressed. So that's the first thing we want to do. I'm going to break this connection here, Control X, and then Control V. That's just an easy way of deleting link lines. It's the lazy way, really. So Control X, Control V, we're just getting rid of those link lines. Notice it still kept those little ones at the top, which is good. So we want to test that it's been pressed and then that it's been released before we move on to the next state. And we might do that to one of the states, and then we would do the same thing to change back again. And you'll notice that I've hooked that up wrong because we need to have true on the right-hand side. So true on the right, and that should go white. Very good. And we might make this true on the bottom of the tool, and now we can hook that up. Now, before I copy those, I might just align them and distribute. And now I'll go and select those two only, and Control C, Control V. Put those about where they need to go. And I'll do it that way. Now, I'll take it back around to the start. So what we're doing, we'll just explain this. LED on. One of the LEDs is on, the other one's off. And we're testing for the switch to be pressed. It's going to get stuck there until it's pressed. When it's pressed, then it's going to test that you release the switch. If you release the switch, then it goes on to the next state. Okay? So these output tools define the states, and it will stay in the second state with LED, the first LED off and the second LED on until you press. It's still going to stay there, and then release, and then it goes to the next state. So that's how we hold a LED state. And let's turn it on. We need some LEDs. Okay, we've got the two LEDs. Let's program. Okay, so pressing the switch down shouldn't change state, and then lifting it up will change state. Okay, and that's how we're going through the pressed and then release. Now, what you might find is that sometimes when I press, it actually triggers. And if I press the switch on a different angle, you'll see it triggers when I press, and then it triggers when I release. Now, the reason it's doing that is because it has a thing called switch bounce. Of course, if I press on the correct side, it doesn't bounce as much, and you'll see it holds the state without swapping backwards and forwards. And that's just because I know where that switch works best and where it doesn't work. The way we can get rid of switch bounce is called debouncing. And to do that, we actually use a delay. And it's a 20 millisecond delay to make sure that it's going to settle. So we'll do that here. We'll call this 20 ms for 20 milliseconds, and we'll actually put in the same value down here in milliseconds. 20 milliseconds, and where we want to do that is we actually want to stop it after the pressed state. So we can put in our 20 millisecond in between here and there. And we also want to put in a 20 millisecond delay in between these two states. And we'll see if that fixes things for us. Program. Okay, so now if I press it, you'll see it doesn't matter where I push that button. It's not triggering until I release it properly. And so that's effectively got rid of the debounce. Although if I do it quickly, I think I just saw it skip. The debounce routine is only somewhat effective. There are better ways of doing debounce by doing consecutive tests, and we might have a look at that in the next lesson. And we might also have a look at using the switch tool, which actually has debounce built into it already. That's lesson 122, holding a LED state. Thanks for watching.